Okay, a classic question. And I think you know what I mean by now. When I say classic question, it means it's probably going to be on the quiz and the exam. So we have our rock. It has a mass in air. It has a mass in the water, parent mass in the water. So we want to find the mass of the water displaced and the volume of the rock and the density of the rock. This is the kind of thing that we'll do over and over again. So here we go. I'm going to convert to newtons because it's important for buoyant force. Force is in newtons. So we're going to have to get our masses in kilograms and then multiply by 9.8 meters per second squared. So we have our rock. We're weighing it in air. In air, it's got a mass of 540 grams. And then when we submerge it in water, it has an apparent mass of 342 grams. Okay? So now, 540 grams is 0.542 kilograms times 9.8 meters per second squared gives us a weight of 5.292 newtons. Similarly, 0.342 kilograms times 9.8 meters per second squared will give us a weight, not a mass, a weight of something here, 3.352 newtons. Okay, so the buoyant force is the difference between the two. The buoyant force is the weight of the displaced fluid, but it's the difference between the weight in air and the apparent weight in the fluid. So it's 1.94 newtons is the buoyant force. Now I know you're annoyed with me because nobody ever asked us what the buoyant force was, but just stick with me. Buoyant force equals density of the fluid times the volume of the object times g. Okay, so now, part A, we want to solve for the mass of the displaced fluid. The weight of the displaced fluid is 1.94 newtons. That's the buoyant force. So that's 1.94 sorry, newtons. Now what we want to get is the mass, which is the buoyant force divided by g. So that's 1.94 divided by 9.8, and that's 0.198 kilograms. Yes, we could have just done 540 grams minus 342 grams and done that. But, important things. The volume, buoyant force divided by density of the fluid times g, 1.94 divided by the density, 1,000 kilograms per cubic meter, times 9.8 meters per second squared, running out of space. The volume is going to be 1.98 times 10 to the negative fourth cubic meters. All right, part C, the density of the rock. That's mass over volume. We have the mass in air. That's the mass we want to use. Mass in air, 0.540 kilograms, divided by 1.98 times 10 to the negative fourth cubic meters will give us a density of 2,727, adjust the camera, kilograms per cubic meter. Now we'll compare that to the density of granite. We have to look that up somewhere. We'll look it up in the book, and it says it's 2,700 kilograms per cubic meter, and that's pretty darn